Creating and solving systems will be helpful when you're given a word problem that has more than one variable. So step 1 would be to define the variables. Step 2 is to analyze the components and create equation. And step 3 is to solve the system utilizing the best strategy, graphing, elimination, or substitution. So here's a first example. A group of 148 people is spending 5 days at a summer camp. The cook ordered 12 pounds of food for each adult and 9 pounds of food for each child. A total of 1,410 pounds of food was ordered. Part A, we need to write an equation or a system of equations that describes the above situation and define our variables. So the first thing that I notice when reading this problem is that we're talking about adults and children. We have each adult and each child, so we are going to label our variables A for the number of adults and C for the number of children. Now the first equation is going to come from that we have a group of 148 people. So the number of adults and the number of children should add up to get 148. The second equation comes from the pounds of food for each. You have 12 pounds for each adult, 12A, and 9 pounds for each child, 9C, and the total amount of pounds is 1,410. So that's going to equal, when you add them up, 1,410. So now we need to, using our work from part A, find first the total number of adults in the group and then second the total number of children in the group. So we are going to use substitution for this problem because in the first equation it would be very easy to get a variable by itself. In fact, if we take the first equation, A plus C equals 148, and we subtract A from both sides, we get C equals negative A plus 148. That's written here. We can then use that substitution. We can substitute what C equals into the other equation. If we distribute and simplify, we get A equals 26. We can then substitute that value into the first equation to solve for C, 122. So you have A equals 26 and C equals 122. So now another equation, we have Tanisha and Rachel had lunch at the mall. Tanisha ordered 3 slices of pizza and 2 colas. Rachel ordered 2 slices of pizza and 3 colas. Tanisha's bill was $6 and Rachel's bill was $5.25. What was the price of 1 slice of pizza and what was the price of 1 cola? So here, when looking at the question, we're talking about a price of a slice of pizza, and the price of a cola. So that's going to be our 2 variables. We have P equals the cost of a slice of pizza and C is the cost of a cola. Now the 2 equations are coming from Tanisha and Rachel's separate bill. We have Tanisha ordering 3 slices of pizza and 2 colas for $6. That's where 3 pieces of pizza plus 2 colas is $6, the first equation. Then we have Rachel's equation, Rachel ordering 2 slices of pizza and 3 colas for $5.25. So 2 pieces of pizza, 3 colas for $5.25. Now we need to solve this equation, the system of equations. We're going to use the elimination method because these are in standard form. These equations are lined up and we can multiply both equations to get common coefficients. So we can multiply the first by 2, changing it to 6p plus 4c equals 12 when we distribute through. And we can multiply the second equation by -3 to give us -6p minus 9c equals -15.75. Now we have our opposite coefficients, so that's written here. So if we eliminate the p variables, that leaves us with -5c equals -375. divide by -5, we get C equals 0.75. Substituting C back into the first equation, here, we can simplify and solve for P to be 1.5. So that means the cola would cost 75 cents and the piece of pizza would cost $1.50. Here's another example. So now we have your class of 22 students is going on a trip. There are 4 drivers and 2 types of vehicles, vans and cars. The vans seat 6 people and the cars seat 4 people, including the drivers. How many vans and cars does the class need? So we're talking about vans and cars, so let V equal the number of vans and C equal the number of cars define our variables. We're going to set up the system. So here, the drivers, we have V plus C equals 4, because if we go back, we've got 4 drivers. So the drivers of the van has to be the total drivers per van. And we'll have 6V plus 4C equals 22 from the information of the 6 people and 4 people. And the 22 students for the people. So solving the system by substitution, we're going to take the first equation and solve for V by subtracting the C. So V would equal -C plus 4. We're taking that and substituting it in to the other equation for V to make it not 6V, but 6 times the quantity -C plus 4. We'll distribute the 6. We'll combine our like terms, subtract 24, and divide by -2 to get that C equals 1. If we substitute that back into the first equation, like so, we would get -1 plus 4, making V equal 3. So if C equals 1, V equals 3, then if we check in both equations, it makes it true, making that our solution.